Firstly, I want to answer the question, not the question. You asked about the solution about corrugation. I think three measurements can use it. The first, for the vigilant fasteners, you can change the stiffness of the fastener. You should choose the proper stiffness, so you can change the wavelength of the corrugation, but you can remove it on the straight line. You only can change the wavelength of the corrugation on the sharp curved track. The second measurement is about lubrication. Lubrication. It can reduce the development of the corrugation, especially on the curved track. The third one is about changing the speed of the vehicle. You should change it sometimes, yes, but it's difficult to use it for the mature lines. Thank you.
Yes, just for your answers. Just now, I think maybe other experts will ask you, is there any countermeasures has been applied in practical, and can you propose some application cases or application?
Application is difficult to application it, but you can explain it by using the numerical model. I calculated by using a real transient contact model. We use the wheel structure with wavelengths. When the wavelength of the structure is close to the wavelength of the corrugation, the peaks of the vertical force examines the maximum. So this is because the dynamic of the track, the dynamical character of the track for the vigilant faster.
Okay, as we all know, the real corrugation is always the common issues in different countries and for different railways. And I think maybe of you, maybe some of you can propose some detailed countermeasures to share your experience with us. And do you have something to say? Oh, maybe Mr. Oma, you can finish your answers.
My answer?
Yes?
Yeah, about, I don't remember your question.
Okay.
Yeah, I think you did some modal analysis and you identified two modes that were negatively damped, so that,
yeah.
Which actually means they will grow in one pass.
Yeah.
So I've never seen corrugation do that. If you go over a weld, you'll get an initial damped response, but over multiple passes, the amplitude grows. So I wonder what's the physical interpretation of these negatively damped modes?
Well, okay. Yeah, I mean, to the best of my knowledge, if we consider unstable vibrations, that's the initiation of high amplitude vibrations. So after a while, you will have high amplitude, which are constant amplitudes. You have high amplitude vibrations, which can be related with corrugation formation, for example.
Can I make a comment? I think the instability is related to the diversion of the mechanical cinematical energy of the wheel set inside the curve into vibration energy. You have a high mechanical energy, which is a quasi-static energy, mechanical energy of the wheel set, which is forced to come into the curve, and part of this energy is converted into a vibration energy, and that gives the instability. And then the instability doesn't go to infinity due to non-linear phenomena that will limit the instability in practice.
Yeah, I agree.
Yeah. Any other comment or questions? Yes.
Matsumoto from Japan. I'd like to ask to all presenters, which do you like, which do you think, which is most important, which is important to plastic deformation or grinding for creepage by production of corrugation?
Yes, it's also the same question we said. Which factor do you think is most important to control or to unlimited the real corrugation, right?
Yes, yes.
Actually, we have finished a new rear construction design. This new rear design. There is no light corrugation. If the prediction model is right, so in the coming time, I will present this paper. I think we can find a solution to eliminate the light corrugation in the tighter curved track. This curved track is really difficult to control. So maybe I think I will give our results in the coming time. I have finished the study work.
Is there any supplement?
Okay.
Okay, I think the most important factor is the standing wheel between the wheels and the resonant track. The one reason is that this is there is a Doppler effect in this formation mechanism.
Yes, I think the periodical change of the vertical load is, of course, very important, but only the changing of the vibration does not introduce corrugation.
Does not.
Induce corrugation.
Yes, induced.
Induced.
Because the corrugation profile inherits the standing wave shape, and the additional uneven wheel are caused on the real head, and thus real corrugation with the increasing wheel passages.
Yes, and I'd like to comment you one comment. In your model, I can't find the contact stiffness between wheel and rail. How do you think the contact stiffness between wheel and rail? I think it is rather important. The produce of corrugation, contact stiffness.
Please accept.
Sir, could you repeat your question?
I think the contact stiffness, wheel and rail, is important for production of rail corrugation. How do you think?
How do you think the contact of wheel rail stiffness of
Contact
wheel rail
spring.
contact is very important for the production of rail corrugation. How do you think this?
The reinforcer stiffness and the contact stiffness.
No. Stiffness of wheel rail contact.
Contact stiffness.
Yeah.
The contact stiffness.
Contact stiffness is
接触刚度。
我知道。
It's rather high, but not is neglected.
Hertz spring. In my model, the contact stiffness is a constant.
Okay, your model is under the rail, not consider the wheel. Okay, thank you.
Okay. Any other comments? Okay. Yes, please.
Yeah, with the multiple wheel paper, I just wondered whether you investigated the effect of changing the wheelbase, so the spacing between the wheels. What effect does that have on your corrugation growth?
Adjusting the wheelbase.
Yep.
Yes, this is very important. Okay, please pardon your question again slowly.
So I think you had a distance of, was it 2.5 meters between the wheels? Have you investigated changing that distance and what effect it has on the corrugation growth?
Corrugation 的影响。Okay, maybe there are two detections. You can shorten the wheelbase or the enlarging the wheelbase. All of this will have a very important influences on the corrugation growth.
I would like to ask the first presenter the question, because in your presentation you state that the stiffness of the fan guard is very low, but how do you predict like the influence on the vertical dynamics is so big? Because in your presentation you show like two corrugation wavelengths. That's very significantly.
You see the calculated model. Your question is about the distance of the wheel contact wheel transient model.
No, I mean like in the presentation you mentioned the fan guard.
Yes.
And then you mentioned the stiffness of the fan guard is very low.
Yes.
It's around like 2 to 6.
5 to 8 kilonewton per millimeter.
And how can such low stiffness influence the vertical dynamics so big? Like in one model you show it's around 100 hertz, another you show it's around 500 hertz.
Okay, time's is up. And thank you very much for your presentation, and thank you everyone.